Okay, so who is this? Whose worker is this one? How to pronounce your name? Mateo. Uh, let me see. Oh, okay, Mateo. All right. So, typically, I would share some works with everyone that I saw something good in the assignment, and then I want to talk about that so we can share the work. But I probably don't have time to go through everyone's work. So, anyway, I want to point out that Mateo's work is very clear. Okay, so like a very good line weight. Like you still can see the entire shape from a distance. And also, I appreciate that he put a plan here so you can understand the curve, right? The input curve. Here, I would suggest, Mattel, that you might want to design your own curve, right? So that's a triangle, square, hexagon, pentagon we are using in the class. So I would suggest you design your own motif that the driver of the curve. However, I appreciate you change the parameters to get this more tower-like work, but still, like I would suggest you do your own design. But here, the good quality of the line weights, I would suggest everyone to follow this convention that at least you should be clear as like this. All right. So I know this is the very first assignment, so we might not have much time to go through all the details. So today I'll just use this as a chance to talk about these things. So just good line weight, good work, very nice presentation, representation. All right. So please remind yourself that remember to produce a good line weight like this, right? And is it Joss? Yos. Oh, Yos. Okay, Yos. So I appreciate that. How do I pen this thing? So you can see Yoast has a very intricate, elegant motif that these curves, and then change the parameters to create different design. You can see the good quality of the design. That's very complicated, and also I think he figured out how to do the diagonal lines, right? So that is very good work. And but overall saying, Yost, I would suggest you put a little bit more line weight. That is a little bit too blurry here, right? So just like a control the line weight. I know if you increase it, it might be blurry entirely. So that'll be a trade-off that might be you might want to reduce the complexity or something. So to represent your work in this scale, that if we enlarge that, it looks very nice, right? You can see this how complicated shape that we can have just by changing the motif, right? So that is very good work. And also others, not only one, but also like this, very weird shape, these kind of two shapes together. And this void space it creates, right? So it's like a void space inside in this corner that all this will go down all the way. And very different representation from the points all the way to the volume, right? And also this one and that one. Oh, sorry. At this. All right, very good work. And this Caleb. Caleb, first suggestion is that please unify the light wave. It's very dark, it's very light. All right, so watch out this line quality to be consistent. And then I appreciate this kind of design, really. It's a very irregular one, very symmetrical one. It tried different things like this one that it's hard to imagine if you put this work, this geometry into it, how it look like, right? So it's like a very complicated shape that there's a tunnel inside, something like that. And also like in the stacking representation is super complicated, right? And you can see this is my favorite, I think. This is probably my favorite. First of all, is like this is almost like a mathematical equation to control this kind of changing, right? So it's not only one, like an extrusion or the one simple curve. Caleb did a very complicated gradient here, right? That's when we change the scale. It's like almost like a sine wave or something. And then you can see this power of the code that this symmetrical motif, and you rotate it, it look very just beautiful, like this one. Definitely can be some applications for some design. And this is super complicated. In this case, I would suggest you might want to reduce a little bit density here, so it's hard to see the overall shape, but still very nice work. And also like different motif and different curvature, right? This one is from the small to the large. It's not like this kind of oscillate, like a waving things. Also, other things are differently, right? So I appreciate that Caleb put a lot of efforts on changing these parameters, right? Very nice work. Thank you, Caleb. There's a Phil, right? That's another good example that, first of all, Lightweight is good, right? It's very clear. The metadata is clear. And I like you to start using the curve. However, this is this code, this script is not designed for curves. So you might have weird representation in a point, right? Because this code would get these kind of kinky points that if you have a circle and it's like a Pac-Man, right? You would get these 3 points. You won't get any points on the curve. So you will just look for the turn, right? The sharp turn like this one. So the join point. So here in this case, you will have only 3 points like this. It's still okay. I would say it's still okay, but just like watch out if this is the quality you are looking for, right? And also like this one, a lot of curve design. I appreciate that. Oh, sorry. Ugh. That when you, I really like this work because you can see this. When you have a concave in your motif, that this kind of corner, like a Pac-Man's mouth, right? This one, it created space here. Right? I really like this quality that it's not only an entire solid thing, but the space start to get into the object. So I really like this one. Also these things as well, that it has the very nice quality about this thing. A suggestion for you is maybe you want to create more rigid shapes to avoid this kind of this very, weird point representation, but still it's very nice. This is a very complicated one. I think you already recognize what it is. It's a KUK, right? So I really like design. When you put it in here, it's like a space inside. Again, very good quality. Like this one, it's very complicated one. I really like this quality and very good line weights. It's very clear. Good work. Also, this crazy shape again, right? The star shape. Very complicated things. Very good. And this Anna's she has very nice work, beautiful lines, but just overall saying the line weight is a little bit too light. But here I really like the way the design she did, like this thing. It totally grabbed the power of this kind of gradient. So you can see this carved in space, the sharp edge outside and the carved in space. I really like this one. A suggestion to Anna again, that lightweight, and also please turn off the hidden line. All right, so that we won't see this kind of hidden line. That'll be a little bit too complicated. And also like this. And now the one, I really like this one as well. It's simple, but it's so like ready for other application, right? Like this. It's just from big to small. It's like a foot or like a base of something. That I think this one is really good, well curated. And also others like a square one, and this one. This is like a the first time I saw it, it's like a Batman logo. It's a little bit weird, but if we are using the curve one, we will encounter the same issue, that there won't be the points here. All right, so you could discrete these things, like this is not a one single curve, it's multiple curves here to get this thing. right? But still very nice because when you put this kind of curve inside, I really appreciate like Phil's work that there's a space inside. Start to get into the space, create a space. Really nice work. Very good. All right. And there's a Hunter. Where are you, Hunter? All right. So Hunter is very elegant design. On the top is so small. So I would suggest you might want to put a motif here and enlarge the overall shape a little bit. Because this beautiful motif, you can see this space again, just like when you have the concave space, you rotated the space come out. So I would suggest maybe you want to enlarge the design that in X, Y direction. It's so thin, so skinny that this space cannot be seen very well. But still, I appreciate this kind of work like this. Very nice, right? Like this one, this kind of space here, right? But because of the proportion of the overall design is a little bit skinny, so you might want to enlarge a little bit so we can see the inside, this kind of space, like a texture on the surface. And also like this one, the star one, very pedagogical. This one is very complicated, but still like hard to read what is the motif here. But you can see this kind of space that you create is beautiful. So I would suggest can enlarge the X, Y so that can make it more obvious. Okay, so that gearbox. Okay, is that the gearbox like you drive like 1, 2, 3, 4, 5, 6? Okay, super complicated. This one I really like. This this is actually a loop like this, but still it looks like a panel, right? It's like a start to change the identity of the surface. That this is a surface, so it becomes surface to a very thin one. It's not a shell one. It's like use the shell itself to become the motif to materialize it, like this one, right? It's like a board, very thin board. I really like this one. This is very good, right? And so if we want to really synchronize all the kind of representation, you will see this very awkward moment because this is so thin. The motif you did is very thin. So these 2 points are very close. So I would suggest if we want to do this kind of representation, you can just use 1 point here. And then you would synchronize the overall representation. But still, very good work. Just try to enlarge it a little bit. That'll be great. The last one I want to share is Alida or Alida. Alida, okay, very good work. That I really appreciate this simple, just rhombus. It's not very complicated, but you can see the curves that created the overall shape is very good. But suggestion here is that you might want to no, oh sorry, no, my bad. So this one is good. I really like this one. It's like a contour line and in a very complex shape. So again, this will be another issue that if you are using curve, that won't have this only have the points that the connected point here. So it will be a pity that show this thing only. So if you are going to use this motif, you can discretize it like a small curves like around it like this, small lines like this, just like make it a polyline. But this one is very nice work. I really like this thing. And you can see the different representation here. That will be another issue that because the lines, the points we are using only one, right? So that you won't have this kind of truss-like surface. So that's a pity. We can revise this a little bit more. And this is another motif, the star shape, very good work as well. And also, I would suggest, oh, this one is good too. That's a concave triangle. It's like an arrow. So again, I really appreciate that the thing that you create the space here. All right. One thing I would suggest is you might want to change the curve here, like how you make the scale, right? Like Anna did this kind of from big to small, and Caleb did this kind of wave, like a sine wave things. There are so many things to play with. So, but still, very good work. right? And good line weight. I really appreciate that. I would suggest like just tiny things that you might want to turn off this outline because it somehow caused the problem to read it. That the some lines are here, just stop. It's not your fault. It's actually the rendering engine in Rhino is not that mature. So if you are turning on this to reveal this line, it sometimes it calculates it, sometimes it doesn't. So it's like it's just not a very stable representation. So, but anyway, I like the line weight very much. Very good. All right. So, as a very first assignment, I know there are some we still miss some assignment. So, I would extend this assignment deadline to today midnight. If you want to make any change, like if you want to increase your line weight, you want to reduce, you want to change your design, you can go ahead by all means. But this is only for the first assignment because next time we need to really keep up so that we can process the project. So I gave the feedbacks here. So if you haven't submitted, please submit it by the midnight today. All right. So and then if you want to change anything in your current assignment that you already submitted, you want to make it better, that's good. You will get extra point. And all the works that you already submit today that I received by 9 a.m., you will get extra points that you submitted because you make it on time. So, but still, if you submit the work by the midnight today, you won't get any reduction, right? But if you want to go back to revise your work, please do. That you still have time that we can you can make it better, right? Any question? Okay. Do you have any? Have you encountered any issue on this assignment that I don't know how to output the drawings? I don't know how to put it into PDF. Anything? If you do, please let me know. All right. So because it's like if we cannot make it right now, it's hard to make it right in the project or in the assignment too. All right. That will be accumulated. So if you have any question, stop me. Let me know. Let me help you. So my workshop is like this. I want to make sure everyone can have the complete Grasshopper code in the class. All right. So you won't worry about the coding part, and you can go back to do the design part, and that's the fun part, right? So, but just let me know if you have trouble in the class. Just stop me, and typically I will just go through everyone's computer to see if you can have the script. All right. Okay. Very good work. Okay, so today we are going to start the assignment 2, attractor field. You can go to module 2 to see the handout. So this is a very commonly used skill to do the parametric design. It's super useful. You will love this script. I still use attractor field a lot in my design. This is my design. I worked with an artist in Atlanta. He was my colleague before, but he said academia is really too poor. So he left Georgia Tech. He became a very famous artist and architect, and then based on Georgia, Atlanta. So that is work I did with him. This thing is under construction now. This is concrete milling. So he's using robot to mill the concrete and to do this kind of facade. And this is designed with attractor field. So there's, of course, the geometry is very complicated, but the on the back, the backbone is attractor field. There are some other attractor fields work very good. I would suggest one work is, you can check it out, is graphic. This artist we talked about before, this work is amazing. His work, he's a visual artist, so everything is in the computer. Everything is just a projection. But the work he did, that he really stretched attractive field, this kind of idea to the limits. That all the work is driven by this concept. So that's for example, this one. That's it's so complicated, and and beautiful. So like this, it's all data driven, but back in the mechanism that is attractive field, nothing else. Just like this, very good work. So like I think his first name is Anado Refik. So that's his work. That's very good. You can see a lot of different attractive fields work. You can recognize them in the end that after this exercise. All right. So you can go to download this handout, and this will be only 2 days. So today and Thursday, hopefully we can cover it. If we can't, let's see. All right. So only 2 days workshop, and then because we spend much time in assignment 1, so I think we all have some foundations already, right? So let's see. So here's a deadline for the this assignment 2, September 12th, and also we need to produce very similar variable, just like assignment 1. We have 16 variations that we need to create. So I will talk about this thing later. Right. So let's go to the workshop we are going to do today. What is this? It is actually also here's a sample. I put out the sample that this is actually what we want to do. That this here. Okay. So I'll use the model to talk about this thing. So attractive field is that a mechanism that we set up some attractors. Attractors like points and line, any kind of geometry. So according to this attractor and the object you are working on, if you are close to the object, to the attractor, you change. If you are far away, you don't change. So we use these things. Sometimes we use it to create very complex geometry. So this is one of example like this. So it's a surface created by the attractor field. So for example, here is actually a point. Here's another point. And on top of this area, you can see this area is another point here. So according to the distance to this grid, so you can see this grid is a lot of cube, right? So every cube, we calculate the distance from the cube to the point and use this distance as the driver to change the geometry. For example, in this case, I just lift it off. Yeah. So if you are close, I lift a little bit. I lift more. If you push away, sorry, I push away. So if you are close, I push away very much. If you are far away, I don't push away that much. So that means if you have if you're very close to the attractive point, I will pull you down more. If you are not close to the attractive point, I will pull you down not that much, right? So the distance between the cube, every cube, to the point becomes the parameter to control the transformation, right? So in the assignment 1, we practice transformation, right? We directly ask it to transform. Like I want to rotate 5 degrees every time like this. Every time I want to scale it a little bit, like 20%, and I follow this kind of equation or follow this kind of pattern. This time, we are going to use another geometry, and according to the spatial relationship, and we use this to control as a parameter to control the transformation and create the geometry, create a design. All right. So this is I put down this exercise in a very different representation. Again, I think that would be great if we just create a attractive field. It might be just we can done in 1 day. However, I like to practice this idea again that even we have a geometry, that a surface like this, how can we represent it in points, lines, surface, and volumes again, right? Just like the practice we did. So this is a point on the surface. That we use the point representation to represent the surface. This is a lines, point and the lines together to represent the volume, right? And this is a completely point to represent the volume. So it's more discrete, right? And then here's the lines. Can we use lines to represent the surface? So there's lines, an X direction and a Y direction, and the combination is agreed, right? So that's we have a lot of things to play with. How about surface? Can we use a surface, X direction surface, y direction surface, and combine is a grid. I think you probably can directly produce this thing, use laser cutter to create a beautiful work, a beautiful model like this. It's like interlocking, right? It's a waffle structure. How about use surface to represent it? The surface stripes and the y direction surface. And how about put them together? This I want to point it out that when I put these two things together, I make more tricks to make it more believable. That can we weave them together? And that is actually the gentleman Caleb's work outside that you can see this kind of wooden weaving structure. I stole their code to just put them together like this. Very good work. So can we do the weaving? So this is a bonus. We can do it if we have time. How about started? The volume, can we use volume, X and Y? And how about the entire volume, right? The entire solid thing. And we can use CNC to carve this out, right? So again, attractive field is a skill that we can finish this thing very quickly. However, how you transform this design into many different representation, give you different quality and different context, different needs, right? When you are going to use point, when you are going to use line, surface, solid. So I want to pick up this idea again. So, and that will help in your studio or in the future, that you know how to represent these things that smoothly transformed into one another, right? Okay, so let's do it. Open your Rhino, please. All right. So let me. So open your Rhino. And your grasshopper as well. Okay. All right. So first of all, we want to. Let me put it nicely here. Okay. So if we look at this very first one, that the point, where is it? Point here. That this very first one, yikes. Now this one. If we want to use these, let's start with this one. Let's create a lot of points, right? So it's a points matrix. And my idea is that if we set up a point matrix, it's a points only, and I set up 3 points, I calculate the distance between every point and the point, the attractive point, and I calculate this distance and use the distance as a parameter to transform, like I want to push it down or put it up, right? So that is my idea. So very first one, let's create a point matrix, right? Okay. So go to your Rhino, just follow me. Your grasshopper, sorry. So how do we create a point matrix? We want to construct a domain first. So double click, construct domain, all right? So please find this one, like as a green bar with the 0 and 1, construct domain. Okay, so it looks like this, construct domain. Okay, domain is a thing that in Grasshopper that, again, the naming is very confusing. Domain is a numerical range from 0 to 1. All right, so it's just range. It's nothing. It's a range from 1 to 2, 3 to 4. Right. So domain has a star at the end. give me the start point and the end, a start number and the end number. I give you a range. So that's a range, right? So from you can set up here. Just follow me. Let's do. I want to create a 25 by 25 grid. So that's why I want to set up a domain first from 0 to 25. So just follow me. 0, 25, 2 sliders. You can check out, use your panel to see the output is actually a domain like 0 to 25, like this, right? So this is a domain. It's a range, okay, from 0 to 25. I'm going to use this domain as a x direction of the point matrix. So I will need to create another one for the y direction, right? So I construct domain. Find this one. It has a lot of different construct domain, like domain square. That's a two-dimensional domain. We are going to just use this construct domain, just like 0 and 1. You can see this thing is a one-dimensional domain, right? So the same thing, 0 to 25. So I'm going to use this as the x range, and this is a y, all right? Okay. And so we have 0 to 25. Now I want to divide this domain. Okay, divide like from 0 to 25. I want to divide it into 25 units. So that every one unit I have a point, right? I have a number. So 0, 1, 2, 3, 4, 5, 6, all the way to 25. You can divide it into 50. So that would be 0, 0.5, 1, 1.5, 2, 2.5, right? So we want to divide the domain. All right. So here is a very confusing thing is called, if you follow me, range. Okay. So this component called range. And the range is a component that we are using to divide the domain. So just follow me. So this domain, go to this domain and steps. That's how many steps you want. All right. So I'm going to set up as 25. Right. So I put it into 25. You can use the panel to see the output. So that means I have 0 to 25 as a domain, and I divide it into 25 steps. So that will be 0, 1, 2, 3, 4, 5. You can change the numbers here. You can see the difference. If we change it to 50, that will be divided into 50 steps. So everyone has 0 and 0.5, right? Everyone the space will be, the spacing will be 0.5, right? So that is a difference. So let's change back to 25. So every step is 1 unit, right? Same as the y direction, we want to use a range. Just double click the range. And the domain, go to this domain. And I will use the same number because I want to keep it as a square. So just use 25 for both. Right? So you can see they are exactly the same thing, that 0, 1, 2, 3 all the way to the 25. The other one is 0, 1, 2, 3 all the way to the 25 as well. Right? So be careful, there are 26 numbers. We have 25 steps, but we have 26 numbers. Like 0 to 1 is 1 step, 1 to 2 is 2 steps, 2 to 3, 3 steps. So all the way here is 25 steps, but we have 26 points, right? The numbers, okay? So just be careful about the numbers, how many numbers here. Okay, so now what I'm going to do is to use these numbers to create a coordinate system. 0, 1, 2, 3, 0, 1, 2, 3. So this is x. I want to use this as an x coordinate and use this as a y coordinate, right? So like 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. So that will be the coordinates on the 0, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, all 0, 25. 1, 0, 1, 1, 1, 2, 1, 3, all the way 1, 25. So I'm going to use these two lists to create all the points, the coordinates for all the points on the matrix. So the the thing I did 0, 0, 0, 0, 1, 0, 2, 0, and 1, 0, 1, 1, 1, 2, and this kind of operation is cross reference. Okay, cross reference. So just follow me. Double click. Cross reference. You will see this kind of weird hexagon, all points like this. This use cross reference. So list A, go to A. This B, go to B. All right. So cross reference is the component to find all the combinations. If you give me a list, I give you all the combination. But the output is tricky. Output is tricky. It doesn't give you 1, 0, 0, 0, 1 directly. It's separated into two lists. So you can use the panel to check out the output. The A is still like this, but the B is different. So that is how it represents the cross-reference. So it will look like this: 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, all the way to the 0, 25. And then 1, 0, 1, 1, 1, 2, 1, 3. Okay, so it represents the combination in this way. You still have two lists. All right, it's confusing. If you have three lists cross-reference, you have three output lists. All right, but just follow me. We don't need to get into this kind of data structure right now. So here, what we need to do is to use this as X, this as a Y, right? So you can see is 0, 1, 2, 3. So there's X, 0, 1, 2, 3, and this Y, 0, 0, 0, 0. So this combination to use this thing to create the points. All right. So just follow me. Construct point. So you can see this icon is like X, Y, Z, a small dot, the construct point. Construct point is a component to create a point. If you give me the coordinates, I give you the points, right? So X is list A, X coordinate, list A go to coordinates X, list B go to Y. So you should be able to see this point matrix. Right? Okay. It should be straightforward. Okay, it should be straightforward. So what I did is I set up a range. I set up a domain. I divided it into 25 steps. 25 steps and on the domain as well. I use this domain's number I create and cross-reference them to create all the coordinates. Right? Would it be too abstract? It's okay. Let's move on. If as long as you can have these point metrics, is okay. Everyone has point metrics. If you don't, let me know. Is that supposed to like something in writing? Construct point. We should be fine. Yeah, you're here. But the visualization is wrong. So I think you are changing to wireframe. Well, you only have one set view.
Oh yeah, it showed up like that last time I saw it, but then
It's weird. Okay, I'll suggest you.
should I move?
What is this? There's so many plugins out of date. You only have one view. It's very weird.
Should I
Can you?
just change?
Yeah, change the computer.
Okay.
Save this file and change the computer. All right. Everyone is good? You all have point matrix? You good? You good? Okay. All right, let's keep going. Okay, so now we have the point matrix. I'm going to set up the attractor point now. So attractor points is I'm going to create 3 actual points in Rhino, and I use this point. Let's create one first. This point to control the calculated distance. So let's go back to Rhino. Use point as a command and create a point just in the center of this matrix. I think it's fine. All right, that is. I'm going to move up a little bit like this. Right? If you don't have the gumbo, you want to move vertically, you can use move command in Rhino. And here is when you press the move, you will see a small option here. It's called vertical. You can click it, and then you can move vertically. So you will stick to the vertical direction. All right. If you have the gumbo, you can just put it up and down like this in the Z direction. Just make it floating here. Right? Okay. And remember, when we create a geometry in Rhino, if we want to use it, we need a black hexagon as a container, right? To associate this geometry, to reference this geometry. So let's double click point and find this black hexagon point, right? And right click, set one point. Go to Rhino, select your point to put it into this container. Now it's here, right? So you can see it turned to green color because you are associating it right now. Okay. And now let's calculate the distance from this point to every point on the matrix, right? So that follow me. Let's use distance component. So you can see a ruler like this and distance. This one. So this is a component to calculate the distance from a point to another point. So the point A will be the attracted point, and point B will be all the matches here. So remember the data structure we talked about before. If I have one item and I have a list and I put it into the calculation like this one, you would do 1 to 1, 1 to 2, 1 to 3. So it calculates all the distances, right? So let's put it here. Let's use the panel to check out. So that's 18 units, 18 something units, 17 something units, right? So these numbers represent the distance from this point, attracted point, to all the point, every point on your matrix, right? So this to here, this to here, this to here, right? You can visualize them. So like use a line, and not the black hexagon one, the one that line with the one we did before, like with a black line with 2 points. This component to create the line. Start point and end point will create a line. So you can use this thing to visualize it. That is, those lines, the length of these lines is actually the distance that we calculated, right? Are you okay? Yeah. Okay. So we can use this thing to visualize it. We are not using this as a geometry, just visualize it to let you know that this is a distance we calculated, all right? So that's turn off the preview of this one. So this is a numerical value that we want to use, right? However, we could directly use this number as we can try it first that we want to move things up and down, right? So you can try it. If we use move and I want to move this point, so the geometry is move, right? I just move it up and down, and the motion is z direction. The the distance we calculate, we put it into the z direction, z unit, and so that would be a vector, right? So moving vector, and we use this thing, we see what happened, like this. You can move your point, you will follow your point. It's fun. If you put up, you see the curvature is smaller, right? If you put down, it's very close, so the curvature is very dramatic. These. That is a very simple way and is a trick that we typically use in parametric design to create a geometry that we don't really deform the surface. We use some algorithm to create a surface. So you can see that. However, we are not satisfied by this thing because the number directly calculated is really the real distance, right? Sometimes it's too big. That's everything just move up that's into another level. So we want to find a good range about these parameters, right? For example, the distance is like 18 or something. It's too big. So we want to say, okay, if you have 18, I want to map it into like 1 unit. And if you have the 15, I want to map it to 0.5 unit, right? So that's how we control the parameters range. Otherwise, we just directly use the numerical values, we calculate. Sometimes it's hard to control, right? We need to move these points, find a very good spot to have the point. So that is the thing that we want to change. So we want to remap our numerical values we calculated to another set of a numerical value. All right, it's like a Celsius to Fahrenheit. All right, we have Fahrenheit here, and we want to map it to the Celsius. Because probably Celsius is easier for this project. We want to map the kilometer to miles. Right? It's just like mapping. It's very simple. So by doing this remapping, we can control the range, how far you can go, how low you can go, right? It's not directly determined by the distance we calculated. So that's what we are going to do. So just follow me. Let's forget about this thing first. Let's delete the move and z. Before we put it in, we do the mapping, all right? So the mapping is tricky, not tricky, sorry. The mapping has a point that we need to know what is your minimum number in your list. What is the shortest distance here? And what is the longest distance here? So we can know that how much range you have in your numerical values, like you're from 1 to 10 or 1 to 12, right? And then I set up another range, like, okay, no matter you have 1 to 10 or 1 to 12, 1 to 15, I set a range. The minimum number should map to 0.1. The maximum number should map to 2. So all the 1 to 15 numbers will be compressed into 1 to 2 range, right? So that's remapping. And so again, like Fahrenheit and Celsius. Fahrenheit is from 32 to 200 something, and it's like a 180 range. And we want to compress it into 0 to 100 Celsius range. So every numbers in between the 32 to the top one will be remapped according to this kind of scale or to another domain, right? So the first thing is important. We need to find what is your minimum number in your list and what is the maximum number in your list, right? So here we have 21, which one is the smallest one? It's hard to find in this way. So here's a component we are going to use. Please follow me. It's called sort list. Okay, sort list. Sort list will sort the list that you give me according to the numerical value, like from small to the big, right? So distance, this one, let's put it into keys, right? Not the values A, is a keys here, right? So remember that the input is keys. So value A is that you can put another list here. It will sort it. You'll be sorted in the same way as you sort the keys. So key will be the same, the major thing you sort, and all the lists that you can put in will follow the sorting method that you did in the keys. Okay. So after you put in the keys, you can check out the keys output. The smallest number will be on the top. The biggest number will be on the bottom, 24. So in this case, the minimum number, the shortest distance, probably somewhere here, is 10.99 units. And the farthest one, probably somewhere here, is the 24 units. So that's a range from 10 something to 24 something, right? So now we can have, how do we get the smallest number and the biggest number? We just grab the first item and the last item, right? So that will be the boundary of our parameters, right? So here, remember we use this list item, very useful one, right? We put it here, and I will set up 0 as an index. I use a panel. So that's how I get the first number, which is the smallest, the shortest distance, right? And we use another list item. And do you remember how to get the last item in the list? We did this in the assignment 1. We calculate the length of the list, right? And we use the length of the list, put it into as an index. However, we need to subtract 1 from the number, right? We have 26 we have 26 items, but we have index 25. Remember, we're computer scientists start from 0 as an index. So we always subtract 1 to do the index, right? So the index from 0. So 0, 1, 2, 3, if you have 10 items, that'll be 0 to 9. The index will be 9. So for the length, how many items you have in the list, is we use the list length, that will be 10, right? So we always subtract 1. So just follow me. List length, right? So the value A goes, the key go to the list length, and the keys go to this list item as well. And this one will be the index, right? So let's put it into index. However, this index should have expression, right? X minus 1. That means no matter what kind of number you give me, I'll subtract 1 from that, right? So click this green button to commit the change, right? And let's use panel to check out. So this is the last item from your list, right? If you don't have this expression, the x minus 1, you won't have the last item. You will have the same thing here, because you go back. If you overflow, like you give me the index that I cannot find, it will go back to cyclic. Like if I have index 0 to 9, you give me 10, I'll give you 0, because I go 0, 1 to 9, and then you give me 10, I cannot find the 10, I go back to the first one, so you get 0. So beware of this thing. So please remember to put the expression here, x minus 1. Okay, no space in between, just x minus 1. Okay, so this is how many items we have here, and we'll use this how many items as a number, subtract 1 as an index to access the last item in the list, right? So we have the lower boundary of this one and the higher boundary of this one. The upper bound as a 24, this one. Okay, that should be straightforward. And then let's do the remapping, right? So the remapping is straightforward. Not straightforward, sorry. Is we use the domain again. We construct a domain. So remapping requires a domain and remap to another domain. So that's use construct domain. Find this again, the one we used before, the 0, 1, this one. So this is a domain start, the lower bound, and the upper bound, the domain end. So that is a numerical range, right? It's a domain. Here like this, right? And now we need to set up another domain that we want to map to, right? So now we have the domain like from almost like 11 to 25, but I just want to map it to 1 to 10, right? The minimum, I will move 1 unit. The maximum, I will move 10 units. So I use this to control. So that's construct another domain, construct domain. Same thing as this one, the 0, 1, this one-dimensional domain. I'm going to set up the domain from 1.00 to 10, and then 1.00 to 50 something, to 20 something like that. All right. So I want to map from another domain from 1 to 10. Okay. All right. So the next step is to use another component called remap numbers. All right. So you can see remap numbers looks like a small funnel, like a green funnel, like this. All right. So be careful. The domain we calculate from the distance. This domain is a source domain. So that's the way we want to map from Fahrenheit to Celsius. So the Fahrenheit domain is the source. The Celsius domain is target. All right, target from this map to here. It has another input, which is the major input, the value. Okay, I know you want me to map from this domain to that domain. Give me all the numbers you want to remap, right? So that will be from the list here, the distance here. Not a solid one here, the distance. I'll put the distance here. All right? We want to remap all the distance we calculated from this one to the value. Okay? So you can see after you map, you can go to the mapped output, use a panel. Every number is remapped to between 1 and 10. All right? It will keep the relationship about any two numbers. Right? If one number is larger than the number, you still have this relationship, but all of them, the scale will be compressed into 1 to 10. Right? So within this range. Right? So that's use this mapped as a distance as a moving. Yes. Let me see. Oh, they are all 1. Okay, let me see. So because here you need to change to 10. Yeah, because we want to map from 1 to 10. Yeah, there you go. Any question? You all have these numbers? Okay. And let's use this thing to do the same thing. Put it into the Z direction, right? Unit Z. So just follow me. The unit Z. And move, right? So these two things. So we use the map to create a vector from the Z direction, and the geometry is this. So this is a motion, right? So we put it into motion. Geometry are the points we create. So these points here, the construct point, the point matrix, these points, we just directly put this thing into our geometry to move. All right. So let me show you again here. So this point matrix, let's put some scribble here. Point matrix. So construct point, this component, we use the construct point component to create this point matrix, right? And we use the attractive points. So let's put scribble here. This attractor point here. And then this is a moving, and this is a moving direction, right? So this go to here. That the points we want to move is the point matrix. It's not the attractor point. We are not going to move the attractor point. We move the point matrix. All right. So you should see this thing. So like we can change the domain we want to map, right? So now, for example, I want to change like a zero, the start point as a 0.01. Let me change to for example, I want to change to the 0.1 as a start point, and the end point is like 20. I want more dramatic, so you can change that now, right? So you can play with this thing. You can see if we change the range we are mapping, the curvature will change as well, right? That means that I set up the upper bound more. You can move more now, right? So that we won't be only confined by the distance directly calculated, right? We can change the curvature now like this. Okay. Let me change it to back to 1 to 10. Right? It's like gravity. Okay. How about if I want to make 3 points, 3 attractive points? Like, okay, I got 1 point, it's good so far. I moved everything according to that. How about we want to make 3 or more points? And then we can move 3 of them. So just like the handout, right? The handout we did, we actually have 3 points, 1, 2, 3, right? So let's do this thing. Let's go back to attractive point here. Let's create, oh, sorry, let's go back to Rhino. Let's create 2 more points, right? Point, I want to set up 1 here. I move up like this. Okay, so there's another point. I want to create another one like this. Go up like that. All right, something like that. I think that's fine. Okay. I don't want to go to the grasshopper and just set up 3 containers to 3 points and do 3 again, right? I want the point matrix to react, directly find the closest one to me. Like for example, this point on the matrix here, it might be closest to this one, not this one, not this one. So I will just use this distance to calculate the as a parameters. Instead of use these 2, I just use this one because this one is closest to me. If I'm going to calculate this point, I might grab this point only. I am not going to calculate this 2. I will just use this distance to do the movement. All right. So I want to create a kind of a structure. So here, let's go back to associate all this. Before we do that, let's disable the distance for now. There's a skill that every time when I need to make a change, I will disable the code on that. Sometimes if you change the code, you do a lot of redundant calculation that you don't want. So typically, I'll just do this kind of disable to disable all the code after, right? Until I make sure that this thing is good, right? So I'm going to associate multiple points. So go to the point container, this one, and right click, set multiple point, right? So let's use the set multiple points here. And go to Rhino, select these 3, all of them, and press enter. Okay. And now you can see when you click this container, all threes are inside the container. They are associated into the container. All right. So I'm going to disable this sort list because I want to turn on this distance now. So I'm disable this one. I'm going to turn on this thing to see what kind of calculation we have. So I'm going to enable this distance. Use the panel to see. All right. So it's weird. What I'm thinking is that can I use graph structure so that every point can have three distances. Now they are all in the lobby, right? Just like we said, they're all in the lobby. Can I separate them into rooms? So 1 point, 3 distance, because I calculate 3 times. 1, 2, 3. If I'm a matrix point and I calculate the distance between me and these 3 attractor points. Okay, so I want to put these 3 into one room. The next one, another room. So I can do more accurate operation. So here, we need to graph this point A. So go to here, let's graph, and let's go back. I'm sorry, not this one. This, point B, sorry. So this is, we separate them into many rooms, right? So this is attractor point. I want to graph every, so this point will have its own room. This point has its own room. It has own room. One room has 3 distances, right? So 1, 2, 3, 1, 2, 3, 1, 2, 3. So like this, right? So this is the first point on the matrix, and it has 3 distances calculated to the 3 different attractor points, right? So we want to fetch, just keep the shortest one. I want to know which attractor point is closest to me. I will just use this distance. I'm not going to use the other 2 distances because they are far away. I just want to grab this one to me. And so how do we get the closest one, the smallest one? We sort this again, right? So here, let's keep this thing back. This one, I want to sort this again. Sort this. Put it in the key. Okay. So before sorting, it looks like this. Like its smallest, before sorting, let me find a good example here. Like this. The smallest one, the biggest one, the medium one is not a good one, right? We want to sort the list to make sure the smallest one is always on the top, the biggest one is always on the bottom, right? So we sort the list. After sorting, you will see that it sorts within the list. So it sorts here. It didn't sort the entire thing. It sorts in a list. So you just put the smallest one on the top, biggest one at the bottom, smallest one at the top, biggest one at the bottom. It doesn't sort the rooms. It just sort the values in the room. All right. So that's use this item to get the first item out, right? Okay. So how this item worked when you have the graphed list, right? So basically, you would grab. So that, for example, this one, the 21, if you put it into the list item, want to grab the first one. So I give the index as a 0. I want to get the smallest one, right? You will go to every list, first item, right? So that's how this item works with graphed list. So I have so many lists. Every list has 3. I put it into list item. I said, give me the first one. You go to every room, say, who is the first item? Come on. And just grab that one, right? So they access that one. So that's how it works in the graphed list. So So that's actually what we want, because we want this number, right? Every smallest one. So this is point one. I don't know which track point I'm using right now. I don't care, because I just want the distance. I just want a distance. I just want to show this distance. Uh, this distance from this point, that point, I don't know. It doesn't matter, right? So all I need is just to grab this shortest distance from this graphed list, and then just put it here, right? So this one is grafted, right? We saw it's grafted. We don't need it, the grafted structure, so let's flatten it. Let's flatten it. And now all the same thing will be this. So we are replacing this output. So we are looking at that distance in the originally we put this output to two components, right? The shortest, and also we use to remap the number. We just replace it with this one. Okay, so just follow me. The list item, go to here. We sort this one instead of that one, and we put this thing into the remap numbers. So you can trace back this one. Oh, it has one more. Is this one the geometry? No, sorry. This is a matrix. This is a distance. So we are replacing this one with this. Right? So far so good. Okay. Second is this one. Remap numbers, the value. Okay. Once you're done, you can enable the component, and that's hide. Let's turn off the preview. And you should be able to see this curvature. Are you okay? You all good? All right, I'll come back.
So this list item, you took it, did you place it in 3 places or just these 2?
Just two. So store list and the value here,
Okay.
and you can enable this one. Let's see. Yeah, you're good.
Okay.
You're good. Okay. Everyone's good.
This goes into the geometry.
No, this one go to the key and the value. The value here.
Okay.
This one, because we want to use this thing to as remap these numbers, right? And the geometry is from the point. Yeah, you're good.
Okay.
Oh, it's not moving. Let's check it out. So this item, flatten it. Yep, there you go.
Sweet. Thank you.
You all good? You all see this kind of curvature? Okay.
I had it before, but then it disappears.
You had it before and it
Yeah.
disappeared. What you've done? I'm kidding. I'm kidding. You're fine. Grafted. You.
I turned enabled I turned the preview off on point and then it disappeared. And when I
Okay.
turned it back on, it
No problem.
track.
Sometimes it's just funky.
Mm-hmm.
There you go.
Oh, okay.
All right. So that is a very easy way to create a kind of surface. I like this kind of surface because it's like a double negative. So like I have a sphere, I carve it out. I have another sphere, another sphere to carve it out. You can have your own imagination on this thing. That's how to create this thing. All right. So that will be the basic surface we are using. So before we go, let's do one more. Let's use another component. Just visualize the entire surface. It is called, double click, surface from point. Right? So let's put all the points into the point, and the U count is actually from the 25, this one. The 25, because we have 25 units on our matrix, right? So this number all the way go to this U count. And the interpolate should be false, I think. Let me double check. Oh, sorry. This U count has to be at express x plus 1. All right. It's a weird thing. It's a count, right? So it's counts because we have 26 points, right? We have 25 steps, but we have 26 by 26 points, right? So you can see the surface we create. That's actually this, the first surface we have, right? Save the file. Please save 2 files, random file and a grade separate file. Make sure you save the file. Right? So that's called it a day. Any question? You all have this surface. This number is from this number. We do the range. We divide the domain into 25, right? But when we put it into the U count, you have to add the expression that is x plus 1, right? And you have this surface. You can play with these points. You follow the points. You can play with this thing, right? Okay, if you don't have any question, let's call it a day. Let's finish this assignment on Thursday. Yes? Uh-huh. Sorry? What? Yes, sure. I will stay here for 10 minutes. So, yeah, if you have other questions, yeah, please. Yep.
Okay, so I'm working on this like side project.
Give me 1 second. Let me
Yeah.
turn off the recording.